Have you ever thought about your mind and your body as, well, two totally separate things? Or maybe even simpler, how the software on your computer seems like it just exists apart from the actual machine?
Yeah, that's a common way to think about it.
It feels kind of intuitive, doesn't it? But this idea, it actually has these incredibly deep philosophical roots.
It really does.
And as we're going to find out in this deep dive, it's profoundly shaped, maybe even surprisingly, the very foundations of artificial intelligence. So our mission today, we want to unpack the hidden influence almost of René Descartes' famous mind-body dualism on AI.
Right.
We'll look at how this philosophy sort of became the early blueprint for AI and maybe where that basic assumption led us a bit astray, and how current AI research is now really challenging those initial thoughts, leading to some, well, pretty fascinating breakthroughs.
And to help you follow along, we've gathered insights from quite a few analyses. Our sources mainly look at Descartes' impact, drawing from critics like Girardeau and Giovanni Ivan, and also, crucially, from figures like John Searle, who really shifted the conversation. Think of this deep dive as a shortcut, really. It'll help you grasp a complex but absolutely vital piece of AI's history and where it's going.
Okay, so this ancient mind-body split, how exactly did it end up influencing AI so much, right from the very start? Let's get into that. Descartes' core idea was what exactly?
Well, at its heart, Descartes argued the mind and body are fundamentally different substances. The mind is, non-physical, a thinking thing. While the body is physical, it takes up space.
Okay.
And the parallel to early AI is just striking. Designers basically just adopted this separation. They saw thinking, the AI's mind, as pure software, totally distinct from the hardware, the body it ran on.
I see.
This conceptual split, as researchers like Bechtel pointed out, it became foundational. And it's kind of ironic, isn't it? Separating mind and body in philosophy became the model for building these thinking machines. We sort of baked that assumption in right from the get-go.
Okay, that makes sense, conceptually keeping them separate. But practically, when you're building this stuff, what was the advantage? Did it make things easier for those early AI folks?
Oh, absolutely. From a practical view, it made modularity much easier.
Right.
You could design algorithms, symbolic reasoning stuff, totally independent of the specific computer it would eventually run on.
Okay.
This abstraction, separating software from hardware properties, it directly enabled things we just take for granted now, like virtual machines or platform-independent systems. Write once, run anywhere that was revolutionary back then.
Gotcha.
And what's also really important here is how this split paved the way for functionalism in the philosophy of mind.
Functionalism.
Yeah.
Okay, refresh me on that.
Yeah. Functionalism basically says mental states aren't defined by what they're made of, but by what they do, their function.
Okay.
Think of like a mousetrap. It doesn't matter if it's wood or plastic, right? What makes it a mousetrap is its function catching mice.
Makes sense.
So this functionalist view massively influenced AI. It pushed research towards creating cognitive architectures and symbol processing algorithms completely separate from any, physical or biological form. Mind as function.
Wow, okay, so that mind as software idea, it wasn't just theory, it actually built this whole approach called symbolic AI.
Exactly, the direct line.
How did symbolic AI work then, and what were those early successes that seemed so promising?
Right, so symbolic AI was largely based on something called the physical symbol systems hypothesis, which again traces back to that Cartesian split. The hypothesis was basically that intelligence comes from manipulating symbols according to rules, like math or logic. So the whole strategy was about abstract operations, totally independent of the hardware. And early expert systems were, well, pretty amazing at specific things.
Like what?
Things like playing chess at a grandmaster level or diagnosing diseases based on a strict set of rules and symptoms. For quite a while, it really felt like that was the path to general AI.
They definitely sounded impressive. But looking back now, what were the big blind spots? What problems did detaching AI from the physical world actually create?
Well, while they were great in those very structured areas,
Yes.
symbolic AI really stumbled when it came to things like basic perception, just seeing and making sense of the world,
Okay.
or adapting to new situations, or learning from raw
That's
experience.
real world stuff.
Exactly.
Right.
It was a direct result of being disembodied, detached from any physical interaction. It became pretty clear these systems just couldn't handle what you might call non-symbolic processes,
Meaning?
the things you can't easily reduce to neat logical symbols,
Yeah.
like understanding nuance or emotion, or just integrating raw sensory data sight, sound, touch.
Right.
All things that are actually crucial for real-world intelligence. It was like having a genius logician who couldn't, recognize a picture of a dog.
So if that pure software approach hit a wall, what started to challenge it? What were the alternatives people started thinking about?
A really major challenge came from the philosopher John Searle, especially his famous Chinese room argument back in 1980.
Ah, yes, the Chinese room.
Searle's main point was this.
Mm.
Just because software can functionally do something, like manipulate Chinese characters based
Yeah.
on rules to produce correct answers,
Mm-hmm.
that doesn't mean it understands Chinese. It doesn't equate to real comprehension or genuine mental states.
Okay.
He argued that computation alone lacks the biological basis and the causal powers needed for actual understanding. It's like memorizing responses without knowing the meaning.
I see. So it's just symbol shuffling, not thinking.
That was his argument. And it tied straight into the debate between weak AI and strong AI.
Weak AI being simulation, strong AI being actual consciousness.
Precisely. Weak AI just simulates cognitive functions, while strong AI aims for genuine understanding, maybe even consciousness. Searle argued pretty forcefully that just running a program, the simulation, could never actually produce consciousness. There was a fundamental gap.
Okay, so if pure computation, the software running in a vacuum, isn't enough for real intelligence, what alternative gained ground in AI?
The big shift came with theories of embodied cognition.
Embodied, meaning involving the body.
Exactly. These theories argue that intelligence doesn't just happen in some abstract computational space. It fundamentally emerges from the integrated interaction between a system's physical body, its environment, and its computational process.
Ah, so it's all connected.
Right. It directly challenged functionalism and that whole Cartesian separation, and it really pushed AI researchers to start looking at biologically inspired models that could maybe overcome those limitations of pure abstraction.
It really sounds like those critiques forced a major rethink. And it's fascinating how the field then started to, actively try to bridge that original mind-body divide.
It absolutely did. What we saw emerging were these really interesting hybrid cognitive architectures.
Hybrid, meaning mixing approaches.
Exactly. They were directly spurred on by those critiques about embodiment and the limits of purely symbolic systems. A good example is Sun's Clarion model. Think of these hybrids as trying to get the best of both worlds.
How so?
Well, they combine the structured, rule-based reasoning of older symbolic AI with the adaptable learning and pattern recognition of neural networks, the more connectionist approaches.
Ah, so mixing the old and the new, in a way.
Sort of. It's a deliberate attempt to fuse these capabilities. It allows for things like internal knowledge transfer. The symbolic part can inform the neural part, and vice versa. And crucially, it allows for better sensory integration. The system can reason abstractly while processing messy real-world sensory input.
Gotcha.
It finally acknowledges that thinking and interacting with the world are deeply interconnected, not separate things.
So what are the practical advantages? Are these hybrid systems actually better? What can they do that the older systems couldn't?
Well, the evidence is pretty strong, actually. Studies show hybrid systems generally perform much better than their purely symbolic ones, especially on tasks that need perception.
Right.
Adaptability to new situations, understanding context, and just being more robust when things are unpredictable.
So more like real-world intelligence.
Getting closer, yes. This whole evolution marks a really fundamental shift in AI research. We're moving away from seeing cognition as just abstract computation in isolation. Now it's viewed more as an emerging property that arises from these layered interacting processes, computation, body, environment, all working together. It's a much more holistic picture.
So, stepping back, what does all this mean for where AI is heading? And maybe for how we even understand intelligence itself?
It suggests a pretty profound shift is underway. That old legacy of mind-body dualism, while it was definitely crucial for getting AI started, it's hitting its limits as AI gets more sophisticated. The move towards integrating connectionist neural network approaches and embodied elements shows that we really need to move beyond those strict separations.
So dualism was a useful first step, but not the final answer.
You could put it that way. The core insight seemed to be that intelligence isn't just about the computation layer alone. It arises from the complex, dynamic interactions between computation and the physical environmental context. This whole progression, spurred by those critiques of Descartes and functionalism, it points towards a broader shift in how we even think about knowledge and learning in AI, moving towards more integrated, less compartmentalized frameworks.
It's really quite something to see how a philosophical idea from, what, centuries ago
Yes, 17th century.
ended up shaping the blueprint for AI, and how wrestling with its limitations is now driving these really exciting integrated approaches. It just highlights that deep link between philosophy and technology, doesn't it?
Absolutely. They constantly inform and push each other. And ultimately, I think this deep dive really underscores something important. While that initial separation of mind from body was a powerful way to simplify things and get AI going, it seems like true intelligence, maybe even artificial intelligence, needs a much more integrated dance, a dance between abstract thought and real physical interaction with the world.
So for you listening, maybe the next time you interact with an AI, like a chat bot or your smart speaker, ask yourself, is it really just thinking in some abstract digital void?
Or is its apparent intelligence actually tied, maybe deeply, to how it processes data from the world and generates responses for the world?
Something to think about until our next deep dive.